Dear mentors, this is the second in the series of videos about problem solving using the bar modeling. So let's recap. The bar model is visual algebra. So it's a model where you draw bars and these represent quantities that are known and also unknown. It's by nature holistic, so that means that you want to capture the big picture and all the relations between your quantities. And it also allows scaffolding and different levels of complexity. It can be used in many different contexts: addition, subtraction, multiplication, division, ratios, decimals, and percentages, which are very related, fraction operations, geometric and spatial reasoning, and statistics. So in this video, we'll explore more the bar model by solving some problems. Before we start, the advantages are that it enhances conceptual understanding, develop reading comprehension skills. It allows algebra without variables. It trains us to detect patterns. It helps students that struggle with English. And finally, it helps solve problems, but also check for solutions. Okay, so let's try this problem out. So problem D, there are birds and dogs in a park. The ratio between birds and dogs is 3:2, and there are a total of 96 birds. And the question is, how many dogs are in the park? These type of problems are very important in mathematics because they allow multiple ways, multiple representations. So if you want to check for understanding, or if you're interested in connecting concepts, you should deal a lot with this type of problems. Okay, so let's look at this problem, problem D, and it says there are birds and dogs in a park. The ratio between birds and dogs is 3:2. And there are also 96 birds. How many dogs are in the park? That's the question. So let's use bar modeling to tackle this problem. So bar modeling, let's do as a bar model. And so one way that the bar model is useful for dealing with ratios is that if I see this ratio, for example, of 3:2, what I'm going to do is I'll draw a big bar, and that bar will represent not just birds or dogs, but the total. So total of animals. So total. And I just break this bar into 5 parts because 3 plus 2 is 5, because the ratio is 3:2. And I'll explain exactly why. So let's break it into 5 equal pieces. And so let's make sure we have these. So these are equal pieces. So the total, it's 5 equal pieces. And every 3 pieces, like the birds take 3 pieces and the dogs just take 2. That's what a ratio means. It's a relation between 2 quantities. And I can see that I'm not lying. That's really what the ratio means. So every 3 groups of birds give me 2 groups of dogs of any given size. So this should be the birds, and this should be the dogs. So that's nice. We know now how to make sense of ratios in bar models. And now I'm told that there's 96 birds, so this is also equal to 96. But so then I know that if 96 has to be divided into 3 equal pieces, and just 3 because dogs take the other 2, so this is just 3 pieces, then I can do 96 divided by 3 to find how big is each piece. So to divide 96 in 3, 90 divided by 3 is 30, and 6 divided by 3 is 2, so that should be 32. Let's check. So 32, 32, 32. So yeah, that's okay, 96 birds. And then the key is that since we did equal pieces, since we modeled this by equal pieces, I can also label the dog's pieces with a 32. And so the answer is evident, 32 plus 32, that's the number of dogs that are in the park. So let's write this. So number of dogs (64), 32 plus 32. And so this is a nice visual way, and you want to insist on solving problems this way because it can check for conceptual understanding. There's many different problems I can do this. I can do this with algebra, of course, or I can do it just with some equations without variables, just thinking algebraically. But this is a nice way with pictures. Let's move on to the next problem, problem E. There are 4 times as many black chips than white chips. So it's a ratio 4:1. If we were to duplicate the number of black chips and add the number of white chips, we would obtain 63 chips. How many chips are in total? So this problem is kind of complicated because there's a mental experiment going on. So let's try to use bar modeling. So first, what we want to do is, as in the last problem, there are 4 times as many black chips than white chips. So we can do the following. And so we could use either one big bar broken into 5 pieces, or as I'll do, 2 different bars where clearly one is 4 times as long as the other one. And so the black chips, let's put them here, there are 4 times as many. So it's multiplied by 4. Okay, so that's the ratio 4:1 that we're looking for. And then I should use another model. If we were to duplicate the number of black chips, let's duplicate the number of black chips, and we commit to this model. So if we were to duplicate the number of black chips, okay, and add the number of white chips, the current number of white chips. So this is how it should look. Black, black, I duplicated, and white. We would obtain 63 chips in total. So this big total has to be equal to 63. And so one nice thing about when you teach these models is that for a second or for a minute, you kind of forget about the final answer, what you were looking for. Of course, you need that, but you're just in the model. You just want to make sense of all the connections. And the first natural question would be, how big is each of these pieces that we use to model? So what we see right away is, since that we have pieces of equal size, and that's part of our modeling, so we have equal size, what we're going to do is 63 divided by, and so we have 4 plus 1, we have 9 little pieces. So 63 divided by 9, and so dividing by 9, okay, you can divide by 3 and then divide by 3 again. Let's do this. So 63 first divide by 3, that's 21. And then let's divide by 3 again, that's 7. Or you could use the knowledge of multiplication tables, 9 times 7, 63. But the point is that we know now that each of these pieces is worth 7. So there's 28 black chips and just 7 white chips. The question is, how many chips are in total? So that's easy also. We just multiply 7 times 5, because when I add black and white, I would have 5 times 7. So let's write that. Total 7 plus 7 plus 7 plus 7 plus 7, or 7 times 5, equals to 35 different chips in total. Okay. Let's do a last problem in this video that also deals with algebra, but let's do it without variables. There are 8 less pencils than notebooks. 8 less. The number of pencils plus notebooks, so if I add them, if I collect them as objects, is equal to 32. How many notebooks and pencils are there? Okay, so that question could be read as how many notebooks and how many pencils, or how many notebooks and pencils as a whole. And we can answer both. It's fine. Let's use the bar model. And so, of course, teachers may be more aware or more familiar with just going to the algebra right away. Even students can solve it. And so the bar model is not sending the message that don't solve it using algebra, using variables, but it's sending another message. You could also solve it visually, and that can help you understand the problem. There are 8 less pencils than notebooks, so my bar for notebooks should be longer than the bar for pencils. So this is what I'll do. There's a difference of 8. So that's the first statement. And then I know that the number of pencils plus the number of notebooks is equal to 32. So what I can do is, if I add the notebooks plus the pencils, I get 32. So as in a similar problem that we did before, what we can do is the following. I can take the model on the bottom that has notebooks and pencils and replace the notebook part using the first part of the model. So what I'm going to do is this end here that you see, I'm going to replace it with this down here. So I'll build my model again. Instead of this n, I'll have p and 8. So I'm just writing my model again, my second model again. And so this should be a p, and this should be an 8. That's my n. And finally, this is my p. And this should be 32. And so now I can see that I can rearrange, and that should be a commutative problem if you were doing algebra when using the equations. So what I can do is this. I have 2 p's and a 32. So mentally I can solve it. 2 pieces of p should be worth 32 minus 8, which is 24. So each piece of p has to be 12. So each piece of p has to be 12. Let's check mentally. 12 and 12 is 24, and 8, that gives me 32. So there's 12 pencils. And how many notebooks? I can go back to my first model in which I knew that there's 8 more. So I have to have 12 plus 8, 20 notebooks. And so if the question is about the total, I can do 12 plus 20 equals to 32. And that's the solution to the problem. Thank you.